Dear students, today we are going to discuss a very important topic of mathematics. Rather, we can say the mathematical physics, that is tensor. So let us look the elementary of the tensor analysis. What do you mean by tensor analysis? Okay. So now, um, in mathematics, the this tensor is an that algebraic object that describes a multilinear relationship between sets of algebraic objects related to a vector space. Once again, I am repeating the definition. In mathematics, tensor is an algebraic object that describes a multilinear relationship between sets of algebraic objects related to a vector space. A tensor is a concept from mathematical physics that can be taught of as a generalization of a vector, while tensor can be defined in a purely mathematical sense. They are most useful in connection with vectors in physics. Tensors were conceived in 1900th century by the famous name in mathematics, the Levi, Ricci, and Riemann. Okay, so this is their output and their outcome of their study as a part of their absolute. This also you can say with the help of differential calculus they develop this subject. Now, if you look in how we can connect your previous knowledge and how in pictorial form, I will try to give this concept to you. Here, tensor is a mathematical representation of a scalar. Scalar means tensor of rank 0. A vector means in mathematics, the vector means rank 1, tensor of rank 1. A dyad means tensor of rank 2 and a triad means tensor of rank 3, etc. It means what is the mathematical definition of a scalar? A scalar means the magnitude without direction. Okay, the number of components are only one and rank is 0. The vector means the rank 1 and magnitude and direction both. The components are 3. Dyad means rank 2, magnitude plus in each direction x, y, and z. The direction is expressed as the sum of 3 components. Okay, so that is 9. Number of components are 3 cross 3, that is 9. And triad means, which you know better, rank 3, magnitude plus 3 into 3 into 3 dimension means the number of components are 27. Okay, so this is the beautiful example of 3D. You know this, and we always try to compute all the directional components. Okay. Now, what is the mathematical definition of a scalar? I think sometimes the student they always incur the mistake during the definition of a scalar in mathematics. The numbers is one, vector means this column vector matrix or row matrix, that is a this vector. Then matrix, this is the rectangular arrangement of rows and column, and tensor means this is the rectangular arrangement of matrices itself. Okay, so this is the multi-dimension. Okay, so now this is the true picture of a scalar, vector, matrix, and tensor. Now, if you go through and look in a variable form, how the differences are there, how we should express into mathematical expression, then this PPT is very nice for you. This means notation, a single number, that is x, scalar. Vector means if this is written an array of numbers x1, x2 like this column vector, then 2D array of numbers like this matrices is called, and tensor is capital X is like X, I, J, and K, that is in subscript. Example like the numbers 1.33 are any number like this, but this is 1 to 9. This is column matrix, and this is your matrix proper of okay, certain rows and certain columns matrix, and this is the combination of matrices. So this is the entries of the matrices in multi-dimensional, you can say. These points, if this knowledge may be expressed into the Python code examples also. So those students who are working in computer science, they know this more better way, and that is if they want to develop their knowledge, then they have to learn about the tensor analysis. And then visualization, this is vector, this you know the rectangular, and this is the 3D figure. So now, if you talk about again in the form of the arrangement, then obviously rank 0 is scalar, rank 1 is vector, rank 2 is matrix, and rank 3 is tensor. So this is and this is very beautiful example you go through. If you write the tensor like this in column vector, tensor TENSOR, then tensor of dimension 6 you can say, or you can say that this is the vector of dimension 6. Okay. If this matrix you look closely, then tensor of dimension 6, 4. 6 number of rows and 4 number of columns. Then matrix is 6 by 4 matrix. But here tensor of dimensions, you look, this is 6, 4, 6 cross 4, 6, 4 and 2. So 6, 4 and 2, sorry, 4, 4 and 2. So 4 rows, 4 columns, and then 2 this edges, this surface. Okay. So this you can write like this. Thank you very much. Thank you.